So myself, Mansi Avdut Mahajan, my native place is Miras, Maharashtra. I have completed my BTech from DKT's Textile and Engineering Institute, Teacher Karanji, and my MTech from Vellore Institute of Technology, Chennai. This year, in 2025, I have done 1 year internship at Intel Technology in Physical Design. Now my internship is completed and I'm actively looking for physical design jobs.
So you have completed VIT Chennai, right?
Yes, sir. VIT Chennai.
Mm, So you might be knowing few people.
Yes, sir.
Uh, so you know Shruti,
Lokhande?
and
Yes.
you know Trisha.
Trisha, I don't know. I
Okay,
know
fine. Intel.
Sanjana.
Fine.
Yes.
Okay, fine. We'll move back to. I just took their names to make the uh, this thing lighter. That's it. Nothing with respect to them. Okay, fine.
Yes.
So you have said that you have done physical design. So now, what's the opportunity you are getting in Intel? So is it physical design or anything else? Or are you
It's
looking for
physical
opportunity?
design, sir. In the first 6 months, I've actually worked in the sign-off domain, FAVE,
Hmm.
Formal
Hmm.
Equivalence Verification, and then in the 6 months, I was shifted to physical design. And in
Hmm.
those 6 months, I studied physical design. But actually, during in the March, they in May they were supposed to convert me, but the new CEO came and the hiring got freezed, and hence they
Hmm.
couldn't convert me, and so the internship got ended like in May.
Okay. Fine, fine. So now, so your tell me about your BTech project. What was your BTech or BE project that you
Yes,
have
my
done?
BTech project was a smart medicine box in which I designed a circular machine which used to deliver medicines 3 times a day. I used
Hmm.
RTC module in that, a stepper motor and a servo motor, which you used to rotate in the circular motion, and the medicines used to will be delivered in the 3 times in a day.
Okay.
Yes.
So what if your motor is out of battery and if it doesn't deliver the medicine on time for the second time or after breakfast or after in the afternoon part, if it runs out of battery and it can't deliver the medicine.
No, actually, there was external battery connected. Like we had a switch. We used to
Oh.
connect it with the power supply. So there was no means inbuilt battery in that. We used
Hmm.
to connect it with the power supply, and we used to means switch on the like that. That project is now working. It's in my home only. I have given to my grandfather, and it's working now.
Good, but the cases, see, assume you are having your grandfather at your home, it's working fine. There is someone to look after the machine also. But
Yes,
what
yes,
if there is a condition where a person is lonely or there is a person who is at home and there are no other people apart from the person and he is reliably depending on that project or whatever the device you are giving. So you are
yes,
saying that you are externally connecting it to a plug. So assume if
yes.
there is no power supply into the house, how can it remind it or how can it deliver the medicine for that time?
No, actually, the we have no backup for that. So we that there is a condition like we should have the power supply in the home. But if we connect it with the inverter port, then it can work. But there was no
Fine.
any
Even
like
if your inverter runs out,
yes, it
right?
will work only when there is a power supply.
So this is a see what happens is that in medicine or whatever you are working with the medical field, you should be more accurate. So you can't
Yes,
depend on the electricity and this, right?
yes.
Fine. Okay. So then, so you said that you used RTC model and stepper motor and all. So what was the code you wrote there? Which language of code you wrote there?
We you wrote Arduino code there.
Arduino. Which Arduino did you use?
Uh, the 16 pins Arduino I used.
There's a
Arduino
naming
Mega.
for that, right? Hmm?
Arduino Mega.
Arduino Mega. There'll be a
Yes.
number for that, like Arduino ET at Mega 2536 2635
Yes,
35 3525. Like, right?
yes,
Okay, fine.
yes.
So, we'll move to your MTech. So, in your MTech curriculum, So you have studied from basics to everything, right? So
Yes,
can
yes, sir.
you explain me how a CMOS is built? Like what are the combinations of transistors your CMOS consists of?
Yes, actually, the CMOS will have two networks, like one pull-up network and pull-down network. Pull-up
Mhm.
network will have the PMOS, which we connect to
Mhm.
the VDD, and NMOS will be connected near to the ground. Uh, and typically, if we see the function of an inverter, when the input one is given, the PMOS the pull-up network, that is PMOS, will drive the output, and when the output when the input given is 0, the NMOS will come in the picture, and it the will get the output, and hence the typical characteristics of inversion took place, and we get a CMOS inverter in that case.
So can you repeat it? You said that when you are giving a input as
One
one, which one will drive?
PMOS.
So if PMOS is driving means if you are giving an inverter one and if you are giving a PMOS is driving means PMOS will turn on, right?
Yes, sir.
So if PMOS turns on, it will connect the VDD to the output, right?
Yes.
So if VDD is flowing to the output, what will be the answer? 1. So you are giving input 1 and you are taking output 1. So how does it become an inverter?
No, sir. Actually, if we give the input as 1, there will be a short circuit created from VDD to VSS, and hence we'll get the and short circuit the it will act as a short circuit, and we get output as 1 there. Sorry, 0 there.
No, no, how can you get a short circuit? See, current is flowing from VDD to VSS. It has to flow through PMOS and NMOS, right?
Yes, yes,
So if you are tapping at the output of your PMOS, that is your drain of your PMOS, right?
yes,
Hmm? So if it is starting from, if you can write it and see, VDD is connected, source is connected, gate and drain. So it starts from VDD, source, drain, and next source, next drain, next source,
yes, yes,
right? So you are
yes,
tapping at the drain of your PMOS. So
yes,
till
sir.
drain, it will reach that one. Whatever the
Yes,
VDD is there, it will reach till drain,
yes.
right? So you are getting, if you check the output there, you are getting one there, right? As per your statements, if it is short means what? Direct connection VDD to VSS.
Yes,
So where are you tapping your output? In between your VDD to VSS. That is
yes,
between
yes,
PMOS and
yes,
NMOS.
yes, sir.
There you are short tapping. So if you're tapping means short circuit means current flow will be there. Direct current flow will go. You are tapping in between them, right? You're
Yes.
tapping in between them, you're getting your output one. So you are giving input one, you are getting output one. Okay, now consider PMOS. Now you know that we'll go even deeper now. Okay, you will have a PMOS transistor. Okay, so in PMOS
Okay.
transistor, what will be your base?
N-type substrate.
N type, N type substrate. Sure.
Yes.
Hmm. So what will be your source and drain?
P plus.
Both P plus.
Yes.
So now you will have your gate, right?
Yes.
So what type of current will you provide? For gate current, whatever you are going to provide, what will it be? VGS, gate to source voltage. Will it be positive, negative, neutral?
It will be negative.
Okay, so you are saying that you are going to provide a negative gate source voltage.
Yes.
Okay, so by providing negative gate source voltage, what will be introduced?
Negative ions will be introduced at the surface of the SiO2 layer.
Hmm. Okay, so if you are saying that SiO2 layer at the surface, it is negative ions are introduced. Fine, I accept.
Yes.
Then go
Yes.
ahead. So how
In,
is this current going to flow there then?
yes, actually, like in the in base we have N-type substrate, and hence as we have provided the negative voltage at the gate, will have positive means that positive, sorry, negative at the this and they will repel each other, like capacitor will be formed near the SiO2 layer, and due to this the current will flow, like it will act as a capacitor plate, parallel capacitor plate in between P plus.
Hmm. So you said that you are providing VGS, the negative ions are formed at the VGS, that is gate side, SiO2 side, like the silicon side,
Yes,
SiO2 side, but the other end, so near the channel, how it is there? You need a channel, right? Near the channel, there should be another layer formed. So how can the channel get formed?
like like the negative voltage and from the base the charges which are coming will
See, wait, you are saying which is the base you said? N type, right?
n type. Yes,
Okay, so you are having an N type in your base.
yes,
So what will be the charges present in your N type?
it will be negative electrons.
What electrons, right?
Yes,
So you are saying that electrons will come close to your gate surface. That is yours, right?
yes, yes,
So you are saying that electrons will accumulate there
yes,
and they will form a channel.
yes,
Sure.
yes.
So if electrons accumulate there, how can they form a channel? Because your channel should be the p type, right? It's a PMOS. How can electron, that is N type, if you are using an N type MOSFET, then you can say that electrons will come and accumulate there. Then we can get our channel formed. But here, your channel is being formed, should be formed by the other type. But how can electrons accumulate there and form a channel?
Like there will be opposite charges from above and below, and hence the channel will be formed and the depletion layer will get accumulated there.
But depletion layer is all fine. But how? How? Because you're saying that negative channel, you're saying that negative ions are going to create a channel. But you are having a base as P type, and you are saying that base as N type, and you are having the source and drain as P type. So source and drain should be, if source and drain are having P type, between them the channel should be P type. So electrons can't form a P type channel. So what are the things that are going to create a channel? That is not electrons. That should be the P type. That should be the holes.
Yes,
Hmm. Then how can electrons form a channel then in PMOS? Okay, tell me which are the charges that are responsible to form a channel in PMOS and NMOS?
like in NMOS there majority charge carriers are electrons, and in
Mhm.
PMOS
No,
holes
not
are the
charge carriers. The ions that are responsible to form the channel in PMOS and in NMOS.
in PMOS they are holes, and in NMOS they are electrodes.
In PMOS, they are holes. In NMOS, electrons. Fine. So now we'll come back to your answer. You said that your PMOS are like your electrons are this one. So you said that in your this one, you'll have electrons, right, in your substrate. So in the
Yes,
PMOS. So how
yes.
can electrons form the channel? That is what my question is.
If we have n-type substrate in the PMOS, it will have electrons as the charge carriers moving in the substrate. And if we provide the positive voltage at the gate terminal, it will like positive ions will get accumulate near the SiO2 surface, and hence there will be positive charge from upwards and negative charge from the downwards, and hence like parallel plate capacitor will be formed, and they will attract each other, and hence the channel will be formed between the two P plus layers in between.
Repeat it again. Let's see.
Yes, in the PMOS, in the N-type substrate, we have like N type n-type substrate we have, which will have electrons, negative charged carriers, and if we provide the positive supply, the positive ions will get accumulated near the
Hold
SiO2
here.
surface.
You
Yes.
said that you will provide a positive supply, right?
Yes.
Just few minutes ago, you said that you are going to provide a negative gate voltage. So how are the positive supply going to be introduced here?
Like if I use the positive gate voltage, then there will be negative, means opposite carriers will be placed in above and negative below, and hence the capacitor
No, no,
it
no.
will
That's
act as a
what.
cap.
See, the
Yes.
question was, what type of gate voltage will you provide? That is what my question was at the initial, right? The
Yes.
question was the negative, positive, or neutral. You said negative gate voltage, right?
Yes.
Now you are saying that you will provide a positive gate, positive ions will be introduced. So how can negative gate voltage provide a positive ions in there?
No, if I change and I will put the positive gate voltage, it will have the positive ions at the
So for
SiO2.
PMOS, you are going to provide a positive gate voltage.
Yes. So for the NMOS, I will provide negative.
So you are going to provide negative voltage for NMOS and positive voltage for PMOS.
Yes.
So by this channel will get created.
Yes.
Mhm.
Like first I will first when I provide the negative uh, for the NMOS, like first it will act as a depletion layer, and when I increase it again above its threshold voltage, the inversion layer will be formed, and the which will the and the VGS will be greater than the VTH, and hence the current will flow in the NMOS.
No, man. See, concepts are wrong. Okay, revise on this topic. Okay, so now we'll move to the next because your basic CMOS theory need to be strong to take anything ahead, and you are completely not okay in this. Completely wrong in this part. Okay, fine.
Okay.
So next
Yes.
thing is, so you have said that you have initially worked in the sign-off stages, right?
Yes. Yes.
So Abhi, so now you have worked in sign-off stages. So in sign-off stages, what is the main challenging role you have done, and what is that learning you learned from there?
Yes, actually, in the sign-off stage, in first 6 months, I worked in the formal equivalence verification using the Cadence LEC tool, in which we used to compare the golden netlist and the revised netlist. We
Hmm.
used to debug it in the Cadence LEC tool, and there was a tape-in period for 4 months in Intel, where I used to run the central runs for all 12 partitions in Pandora software, and I
Hmm.
used to debug in the Cadence LSC, like floating inputs and dangling outputs, and the comparing the golden and netlist, and I used to provide that debugging report to my mentor
Hmm.
for all
Okay.
12 partitions.
So you haven't touched anything with respect to the DRG parts?
No, the like that was the layout part, layout verification, but I was in the formal equivalence verification.
Okay, now tell me what do you mean by LEC?
Logic logic equivalence checking.
I didn't ask for the full form. I asked what do you mean by LEC? So what is it?
Like we'll take the golden netlist, which is considered as the RTL netlist before starting the uh, physical design steps, and the golden netlist is the revised netlist is the netlist we want to check during the physical design process. We will take the two netlist and we'll compare them in the Cadence software. Like we'll take the golden netlist as the reference, and the revised netlist should be the same as per the golden, and we'll check the logical connectivity between the golden and the revised netlist, you using like non-mapped and non-equivalent, like that.
Fine, but why do you have to check it?
Like for in the golden netlist, we'll have one inverter, but the place for the physical design process, we'll add some 2 3 buffers in the revised netlist if we want to introduce some delay. So this will change the functionality, but because of adding these two buffers can disturb the design and can create the missing inputs or dangling outputs. For that we have to check that and report that these two buffers are extra in the revised netlist, which are not present in the golden one. And actually,
How can adding a two buffers can create an issue? Adding a two buffers is nothing but adding a delay. That's it, right?
yes, this will
So that can't create a dangling input or dangling outputs anywhere.
Yes, but when we open and see the design in the Cadence Innovus in the floor plan or placement stage, the model placement will get disturbed, and the timing performance and the PTPX performance, which has to be met the target, will also be disturbed. For when we have the timing issue, we have to check the dangling nets, which are extra in the in revised. And we have when we have the PTPX or target issue, which we are getting at the corners, we have to check for the buffers and the extra inverters that are add to introduce the delay in the circuit.
But not only the question relates to me, questions is the same again because see you add a buffer or you remove a buffer that is only going to contribute in the timing, right? It is not
Yes,
going to contribute anyway in the logical changes. So you're logically assume you have an AND gate. If you are connecting another inverter on top of it, so the output will be the inversion of your AND gate. The output
yes,
of your
yes,
buffer will be. So if we
yes,
add two buffers in between the AND gate and NOT gate, it will still be the output will still be the same only. So logically, you are not changing anything there. So this is not a logic equivalence check, right? So there is nothing doing here.
No, but as we compare, you means what we used to do. We used to load that DB in the Cadence Innovus. We used to check the module placement, and if we don't want that part to sit there, we used to place the blockages, and we used to report the physical design team that the standard cells placed in this region, which are detected in the revised one, should be removed, and they are degrading the timing. Then they
Then
used to remove that.
then that's timing. So that doesn't have anything to do with LEC. So LEC has nothing to do with that part, right? So
Yes,
you are
but in the
placing here
cadence
because you
LEC,
want to meet the timing, but LEC is not that thing. So logic
yes, but
equivalence
we
is
can see this
different.
in LEC only, like non-equivalence and not map between the two.
You said that to meet a timing, you are going to add a placement blockage and ask the PD team to not to include these modules at the certain area to meet the timing. Okay, this is all timing part, STA part or timing part. So where is the logic equivalence coming into picture? So logic equivalence means what? You have to understand what logic equivalence is that. So logically, if both the netlists are same or not, or logically both the things are fine or not. So is there any logical change in between the revised netlist? So assume if there is an inverter before AND gate, and if the output is the inversion of your AND gate, assume if there is one more inverter getting added in between. So the logical output after an inverter, what you are getting is different. So in golden at least A, B were the inputs for your AND gate, and your output of your AND gate would be A plus A and B. That is A and B, A dot B, and output of your inverter would be A dot B, the whole bar. So this is your
Yes,
output. But
yes,
when you compare it to the other way, means in the revised netlist, assume if there is an inverter added in between. So there are two inverters added, A and B. After that, you have added one inverter. That is PD team has added one inverter, and after that, regularly there is an inverter. So the now output will be what? A and B double bar. So the bar gets cancelled. So the output will be A and B. So it should be A and B whole bar. It became A and B. So here you are having a logical inequality, right? So
yes,
unbalanced logic. So this is
yes,
where your LEC comes, right? So this is where you work. So logically equivalent check. So logically equivalence means what? Are both the netlist logically correct? You add buffers, you add inverters, that doesn't matter. You can add inverters 1,000. You
Yes.
can't add inverters 999 because if you add 999, even number of buffers will happen and it will form a logical inequivalence. But if
Yes.
you add buffers in even numbers instead of odd numbers, it will be fine, right?
Yes.
So this is where you have to work. So how did your answer relate here in the LEQ? LEQ. So the module placement blockage doesn't matter, right?
Yes.
Hmm. So you have worked there for 6 months. The very basic. Okay. So apart from LEC, what did you do in the first 6 months of your intern?
And I used to run the central runs for all 12 partitions in the Pandora software, and I used to report the count of non-equals and not map, and also learn how to like debug the log files, the errors, the design not equal part, like failing points, like that analysis, the reports, and I used to report that like these are the non-equals not map, and then he used to like debug it and submit it.
Okay. So what are the common errors you faced here?
Like
What
the
are the common errors
miss
you can debug and what are the common errors
yes, the
you
inverter, the inversion part at the output, like mainly the mux and the flip-flops we used to, what if it's one we are getting zero, then the missing like floating inputs and dangling nets we used to get that. And there was the issue in the LCP scanf file, like the which like after finish cadence with the LCP scanf file will be generated, and then we'll perform the extraction. But the if the LCP scanf file is not generated properly and we run the extraction, then we'll face the issue of the not map points, and then we used to report them that the LCP scanf file has not been generated, and hence we have you have to run the finish cadence again, and then we can run fav again.
Okay, fine. So now then we'll move to this PD part. Okay. So tell me what you exactly did in your PD of 6 months.
Yes, actually, first 1 month I was concerned with the running or the runs. Like every day I used to run 2-3 runs as guided by my mentor. We used to make changes in the scripts like was.tickle, then like the um, clock gating and all. We used to change the flop counts like min flops 4, 6, multi-bit flops like that we used to run. And after that I used to run the extraction, STAPT, netlist mapping and PTPX part in the Synopsys prime time. And I used to update the Innovus numbers, and like I used to compare like this the timing of this run is better than the previous one, and we used to check in that tag for the sign off stages.
Hmm. So you said that you are changing the numbers of multi-bit flops, etc. and all, right?
Yes, yes, yes.
So what were the changes you are able to see from that?
Yes, actually, using the multi-bit, we used to see the changes in the timing. Like we were mainly concerned for the four corners, like mid, norm, mid, min, norm, mid, and high. So
Hmm.
for that four, we used to check the timing, and if we use the min flops as 16, we used to get timing as improved. For the critical was the mid one, but for that we used to get the timing good. But when we see the PTPX results, there was certain target of achieving that number in the PTPX CDAN power, but if the timing is increased, we used to get the degradation in the PTPX power. Then we used to like make the changes in the floor plan. We used to check the module placement. We used to change the standard cells orientation, and after that, after the placing the blockages, we made many trials. Like from January we were doing various trials till May, and we were comparing the results. Like uh, so we got after that we got some relaxation in the target, and now it has got balanced. Like
So you are
we
saying that this changes is just a
yes,
trial and
yes,
run
yes,
method.
yes,
So you're
yes.
not so nothing like with respect to the manual things you have done. It's just changing
No,
the numbers and dumping the reports.
yes, yes, yes. Actually, first 6 months where we were like we were making our step closer to the target now, but unfortunately when I was leaving the Intel, we met that target, like we went close to that target. After that they were going to use the VT swaps, and they were going to enter in the ECO phase, but I didn't uh, I didn't got the opportunity to learn that.
So what exactly did you phase? Did you start working into PD? At what phase exactly?
uh, like in the starting phase only, like the project got sanctioned, and in after 1 week I was means I was like given the
That
PD
is
work.
what I am
I have
asking. In PD work, like you have, if you go with the PD physical
Yes.
design, there are steps, right? There are places, like there are 3, 4 steps that are going to happen in PD. What are those? So where did you enter there?
In the starting phase only, like I used to run from the starting to end, like synthesis to the
So
router.
you know what all steps happens in PD?
Yes,
Can you tell me?
like first synthesis, then
Hmm.
import design, then partitioning, floor planning, placement,
Hmm.
routing, CTS, and then finish cadence.
So now you said that you started from the first phase, right?
Yes,
So from synthesis you started.
yes,
So you in synthesis all of this you did the number
yes,
changing your base. So then what happened? You did floor plan.
yes, I did floor plan.
So what was the count of your macros?
Uh, there were 51 macros.
51 macros. Okay, what was your instance count?
It was actually a big number.
Like yes, you need to know the number, right?
Yes. Like we have 7 intellectual properties in that, 51 macros, and instances I'm not remembering.
So if you don't know the instance count, how can you do a placement like easily? How can you balance your placement? So you did placement stage.
Yes,
So your cells got placed everywhere.
yes,
So were there any congestion?
yes, there were congestions. Like
So
uh,
what did you do to resolve those congestion?
we used to modify the IVAR script, and
What script?
IVARs,
Okay.
IVARs.tickle, and we had like for every stage we had certain script, like placement pre.tickle, post.tickle will have the outputs and the reports, like what we got from that, it has that count. And in the pre we used to like like clock getting, mbit exclude, we used to like comment and uncomment for the timing, like for the congestions. And then we used to like change the positions of the standard cells, place the hard macros, soft macros, and partial macros.
Fine,
Like
but my question was very straight. So how did you resolve your congestion? So what was the congestion number in your design? There will be a congestion number, right? A particular number, this much, that much. What was the number? You didn't check the reports.
no, actually I was concerned with the running that part, like the
I'll tell you
PT
one
set.
thing, Mansi.
Yes,
So now we are entering into the zone of artificial intelligence. Okay, so it's
yes,
2025, hardly 3, 4 years. So the tool will automatically run everything by itself. Okay, the
yes,
only manual intervention is the manual brain or the man's brain that is going to work there will be with respect to the reports and analysis.
yes,
And sometimes even the tool will give an analyzed report also.
yes,
Okay.
yes,
Here we need the manual brain. Runs can be fired by even if I train a 10th or even a class 10 person, if I train him to press few buttons or press few links, he can run everything. That's not a big deal because every single person in this world from now are able to operate a mobile at the age of 5, and by the
Yes.
age of 13 they are able to operate a very good a good laptop or good computer. So that's not a big deal for them. So what
Yes.
I am asking is that congestion. So you have done it or not?
No, I was only concerned with the uh runs running at the part, and after that the extraction till PTPX and updating the Innovus numbers and PTPX numbers and comparing the timing and reporting them which is better and which is not, which is worst like that.
Okay, fine. We'll come to the timing part. So you said that you are going to compare the timing. So what was the worst scenario for which case of scenario? That is, which case of corner you got a worst numbers and how much was it?
Like it was for med. So med was the critical corner of the four corners we have. So for that, there was means very large variation from the previous. Like it used to vary from 8 or 10 numbers from the previous one. But like if we get worst timing, we were getting the good PTPX report. But till I was there,
Numbers,
we
numbers, numbers.
yes.
What is the TNS? What was the WNS? What was the FEPs? You haven't checked anything with respect to the report. You'll have, you see, timing numbers is that is right. Only three things in timings. You'll see
Yes.
TNS, WNS, and FEPs.
Yes.
So you need to know that number, at least one number for this much FEPs, this much TNS, this much WNS.
Like 19,000 was the WNS count.
19?
Yes.
9. Come again?
Like 1980 was the last count for the WNS when I
1980
yes.
PS.
Yes.
1980 PS.
Yes.
So what was your clock frequency of your design? One nine eight zero PS means you know what you're talking. The clock is very small. I don't think there exists any design in this world which is having 1980 PS of WNS. So if you take 1980 as WNS itself, it would go somewhere around 19 lakhs of TNS if you consider this as only 100 FEPs. Sure with the numbers? You checked it or not? Timing, TNS,
Yes,
WNS?
actually I checked it, but now I'm not remembering. Like it's actually it's 1 month I left into.
Mansi, see, I'll tell you one thing. You have worked for 6 months, even only in PD in 6 months you have worked. So
Yes.
that's more than like 26 weeks. Okay.
Yes.
So if you have worked 26 weeks in your this thing, so you have worked somewhere around 180 to 182 days. So
Yes.
if you have at least looked into reports for half of the 182 days, that is 90 days, I think at least one number, any one you could have remembered if you had genuinely looked into them, even after being 1 month later.
Actually, the final check was for the PTPX. Like our target was 72. 72 we have to
What
reach the
what is that 72? Is it WNS, TNS, FEP?
No, it was average powers, average C-dyne power.
Power. I don't want to talk about power. I want to talk about timing numbers. Power we can manage. Power is fine. We can use a different VT types and we can do that.
Yes.
Timing numbers. Power is not a concern for me, no. We are talking about the timing. So fine. Okay. So you will skip this placement part and we'll come to CTS. So what was the type of tree that was built in your CTS?
Uh, Actually, I don't know, but it can be H3.
You say that you don't know. It can be. You are guessing. How can you say that? So you did CTS also, right?
Yes.
So how
Actually,
did
I
you build
just
your setup?
did the run part. Like I didn't do any manually CTS designing there.
At least you should have opened the database, understand where the clock is coming from, which port, how is looking. You could have selected, right? You worked in Cadence Universe.
Yes.
So can you tell me what is the command to select an instance?
A get DB instance and the instance name, or we can give star. It will give all instances.
Get DB instance.
INSTS. Then if we give star, it will return all the instances,
Hmm.
and then we can like select one instance, and we can see the pins nets of that.
I want to particularly select a clock instance. What would be your command?
Get DB inst and then that instance, and then after that dot, it will give like what we have to select after that pins nets of that
Hmm.
XY coordinates.
Hmm. So by this way, you are going to select a particular instance.
Yes.
Okay, I just want to select the instance by its name, by cell name.
Okay, then we can give like we can get DB instance, that instance, then dot name.
Mhm. No, you have already given it by the name. You're calling it by the name, right? So if I assume before I want to select a clock cell, clock
Okay.
inst. So you said that get db inst, and you said that give the name of the clock. So this is
Yes.
going to select the clock of by that name, whatever the instance it is select. I want to select particular by name, particularly by the cell name. So for every cell there will be a naming given, right? For that, by that name I have to take it, or whatever the cell name I have. With that cell name, I have to select all the cells present in my design. All the instance of that particular name should be selected.
Then that select get DB instance in bracket select object.
What object are you going to select?
Like which means what we have selected in the design.
No, you haven't
What
selected. I want to select it using the command. How can you move and just go? See, there'll be like lakhs of instances. That is 1.2, 2.2, like that instances will be there. So you can't just go from top to bottom and select each of them manually, right?
Yes,
For
yes,
macros, you could do 55 macros, you could do manually. But in
yes.
command, if you want to select all the clock buffers, how can you select it?
Like select object log buffer and then star.
Hmm.
If we do that, it will get highlighted in the design, like
Hmm.
in different color.
Hmm.
So and if we give star after that, it will give the list, and from that list we can pick one.
So you used Cadence Innovus or Cadence anything else?
Cadence innovation,
Is it basic legacy Cadence or the other one?
basic one.
Legacy Cadence, you're saying?
Yes,
The comments what
like
you're
we
saying.
had that Lego file,
Hmm.
legalization file. We used to source uh, in the design and check whether check Lego, place Lego, and we used to check see whether the cells are placed in the same way.
Okay, fine. So one last question. So
Yes.
you did routing also or not?
Yes.
So you said you have done routing. So what are the challenge you faced while doing the routing?
Like the cell overlap was there, and the the standard
Cell
cell overlap.
overlap in routing.
Like we
Cell.
used to get the ERC violations in that, like
No, no, no.
connection violations,
We'll,
like violations.
we'll go on by one. You said that cell overlap in routing. You face cell overlapping in routing.
No,
Then where did you face it?
in placement.
Huh. Then why did it come in the routing?
No, in routing will face the electrical connections, like interconnections violations,
So what were them? What are those?
like ERC violations, electrical rule check violations.
What do you mean by ERC violations? What are those?
There will be mismatch like they will not follow the ERC rules for for the interconnections between them.
Is what? What are the ERC rules? What is ERC rule? So Mansi, uh,
Yes.
I think Intel didn't retain you, right?
No.
So there are other people also retained in Intel now,
Yes.
right?
Yes.
So you can you relate what's the difference that is making for them to retain and not you to retain?
Like uh, in the first 6 months, I had one intern with me. She was in layout verification. So in the December, only one vacancy came, and they took her. And
No,
actually,
no, no.
they
See,
yes.
listen. That is what I'm asking. Can you understand what is the difference between you and the other person who was selected? Why not you?
Actually, her work at that time was more like I was only running the central runs part for the FAV, and actually she was debugging the all 12 partitions using the layout verification.
So what you
Yes.
have to understand is that the difference what she made is that even she might have ran the things or she might have debugged it, right?
Yes. Yes.
Right? Even she might have ran the runs, right?
Yes.
But she did the debugging. She understood the
Yes.
concept. She knew what to do, right?
Yes.
What
Yes.
you did is you just ran that things. So to run a script or to run a runs, we can there are tools and we can hire a very basic knowledge person to do that. You are an
Yes.
engineer at Intel and you have done your masters from VIT means that has to be there, right? So that is why the Intel didn't retain you and they retained there. So what
Yes.
you should have done is you should have understood every line. So what you are running, what it is running, how it is giving the output. You should have communicated with your seniors. You should have understand what is CTS. So I'm asking you a basic step of placement. You're not understanding, not even CTS, not even route, and you're not even understanding the basics of very basic, not to the PD part, very basic of inverter part, so very basic of short circuit. These parts are the things that makes the difference. So this is the things. These are the things that the other person have understood and you are not understood. So they have retained. You are not retained, right? So you should have understood
Yes.
this, right? Every time when you are running anything, read the script, what it is doing to line by line. So placing a run in the morning and checking in the night is easy. Everybody can do that, right?
Yes.
So
Yes.
now what you have to do
Yes.
is the feedback. What I'm going to give is start from the start first. Go to your digital
Okay.
electronics. Start your
Yes.
everything that is logic design from gates.
Yes.
Everything
Yes.
once you revise with the gates, then your combinational circuit, sequential circuits, timing, clock, everything. So after
Yes.
that, learn your CMOS theory well, basic semiconductor physics, CMOS
Okay.
theory, how is PMOS, how is CMOS, what is channel depletion layer, what is gate, what is source, what is drain, how the channel forms, what is minority charge carriers, what is majority charge carriers, what is drain current, what is source current, what is gate current. So how is it is driven from one to other, how is it combinationally put into together. So this CMOS part you learn. After this part you come to the your basic analog electronics. So there you learn about some MOSFETs, transistors, SCRs, diodes, and then go to your network theory. Try to understand bit of network theory, current flowing, the voltage, current, this part. Then come to your physical design. Understand the flow first. So what happens in floor plan? What happens in placement? So what happens in power plan? What happens in your CTS? What happens in your route? So you have to understand
Yes.
what input you are giving, what happens inside there, what are the challenges you are going to face, what is the solution you are going to find out for them, what is the reports you are going to see. These parts you have to go in depth for floor plan, placement, CTS, routing, everywhere. And you don't need any resources. You can just type everything on Google. You'll get lot of websites, everything explained very neatly. Go through each of them step by step, understand.
Yes.
So if
Okay.
you are entering into the industry just to place errands, you can't sustain anymore. Hardly 6 months into any company, they'll kick you out. If you know the
Yes.
concept, only then you can do. Reports, the tool will dump. If you have a very good software, the tool will only do the analysis. The only
Yes.
difference that you are going to make is that you have to give the tool to what to analysis and what are the settings you have to give, that you have to give the tool. Okay. So that makes the
Okay.
difference. So you have to do everything from first now. So whatever the 1 year you have spent in Intel and the 1 year you have spent in your VIT, both has to be put into the efforts. And from today you have to start it. Otherwise, it's very difficult to sustain in VLSI. So assume this is the same interview that has happened in your any other company XYZ that is giving
Yes.
you more than very good package. What you are earning double the package that is offered, and if you go and fail there, you will lose your self confidence for any of the other interviews.
Yes.
So the preparation is important. Otherwise, it's very difficult for you to sustain in industry. Not
Yes.
sustain, even give an interview in the industry. Start
Yes.
from basics, then you can get it done.
Okay. Okay, sir.
Fine. Okay.
Yes. Thank
That's
you.
it for today. Okay.
Yes. Thank you, sir.
Okay. Bye.